All right, so let's talk a little bit more with pH here. Again, I just want to quickly remind and make everyone aware that, let's say we have an H3O plus ion concentration of, what did I have, 3.59 times 10 to the negative 10th molar, okay? Obviously, if I want to know what the pH is for that, then I would take the negative log of that. Okay, that's my pH. Now my answer should be pretty darn close to 10, just a little less than that. About 10, just a little less than 10. And when I type it into my calculator, I get 9.44, which makes sense for a pH for that. Okay? Now, we also have something called the pOH. You don't see it very often because obviously bases can have an H3O plus ion concentration. It would be very, very, very weak, and so that's why you get high bases. So remember that if all your exponents for your concentrations are negative exponents, when you take the negative log, they become positive. That's why your scale is 1 to 14. The larger concentrations of H3O plus are the ones that have the lower pH. The ones that have, so again, remember if you have H3O plus ion concentration, if it's something times 10 to the negative 2 versus something times 10 to the negative 11, this number is larger. I don't know how well you see that blue, but this number is a larger number because it's negative 2 versus negative 11. All right, so when you have HCl plus ion concentration that's a little larger, that's when you're going to have more acid, and so it's a lower pH value. Now we do have something called the pOH, and it's as simple as taking the negative log of the OH minus concentration. No big deal, it's as simple as that. You know, if I have an OH minus concentration, and I wrote one down here, 6.25 times 10 to the negative 4 molar. Well, it's going to be the, pOH. Let me get a different color. That black's probably not very readable either, but the pOH is going to be the negative log of that. So we're going to be pretty darn close to 4, right? A little less than 4. And if I type it into my calculator, I absolutely do, I get 3.2. All right, so that's the pOH. Now, we don't use a pOH very often. You usually just see pOHs. But what's nice about pH and pOH, it runs the whole scale. It runs the whole scale. It is, and this is what I really wanted to get to, is the pH plus the pOH is equal to 14. That's why the scale goes to 14. So your pH plus your pOH equal 14. Okay, pH plus pOH equals 14. That's why your scale goes to there. Now what you see also on here is you can determine, since you, again, let me grab a different color. If you know your pH or your pOH, you can determine the ion concentration. You're just taking the inverse log, okay? And again, let's think about it. If I have a pH of 3.5, then my H3O plus ion concentration is going to be something times 10 to the negative 4. And I hope you recognize that, so when you do type it into your calculator, if you don't get that negative 4, then you know that you probably did it incorrectly. All you do is take the second log, the inverse log, the 10 to the x. It's making this number into an exponent. So there's your 10 to the x. So second log, on your calculator, you would type in, most calculators at least, you can't really, the second or inverse log. This is on most calculators, you would type the second, the inverse log of negative P. And I won't put H because it would be the pH or pOH, the negative P value, okay? Now I want you to recognize that you do have to add that negative, okay? And of course the H, the pH, goes with the H3O plus ion concentration, and the OH corresponds with the OH minus concentration, okay? So pH, H3O plus, OH, pOH, all right? So that's kind of where we're at right there. The next set of videos will kind of go a little further on that.